Hey everybody, today for LeetCode question of the day is 199, binary tree right side view. Given a binary tree, imagine yourself standing on the right side of it. Return the value of the nodes you see ordered from top to bottom. So we look at this binary tree right here, there's 3 levels, and the right side is the furthest right node of each level. So here's one level which has a singular node, so that's 1, that'll go into our output. The second level has 2 and 3, so we'll take the right node of that, which is 3. And then we have 5 and 4 right here, and the rightmost node is 4. So the optimal solution to this problem will be using breadth first search, which will be iterating through all of the items, or all of the nodes in the tree, one at a time, which is O of n time, where n is the number of nodes. And this will be O of n space. In the result of the worst case scenario, where imagine the 2 and 5 are gone, then every single node in the tree will be in our output array. So that's the worst case, and we always base complexities off of worst case scenario. So let's go ahead and create our list that will store the result. And now we're going to do a quick edge case check. If there's no actual nodes in the tree, then we're going to return our list that has nothing in it. So if root is null, let's just return result. Now that we've done this check, we know that there's at least one node, and we can begin breadth first search. In breadth first search, you always want to use a queue, and we'll put the first node of the tree, which is the root, inside of the queue. And now breadth first search involves iterating through every single node, so your condition will be while the queue is not empty, which means there's still a node to traverse. We want to iterate through the next floor, so you want to create a size variable which is equal to the size of the current queue. And the reason you want to do this ahead of time is because as you're iterating through the tree, you may add additional nodes in, which will keep manipulating your size variable. So you want to get the size before you add any extra nodes in. So now that we have that variable, we can iterate through all of those. And basically you want to say, in this for loop, you'll be iterating through one floor. When you go from I equals 0 to the size, that's one level of the tree. So if I is equal to size minus 1, which means we are at the rightmost node of the level, that's what we want in our output array. So we can do result.add, and sorry, I made a quick mistake. We want the current node while we're in this for loop, and this node will be the one we add into our result array. And also we want to add any additional nodes we see along the way. So for example, when we're at 1, we'll also notice that there's 2 and 3. So we want to add that into our queue for future traversals. So we'll do this for both left and right. And at the end of this, you will have traversed every single node, and at each floor, you will have taken each node, and if you're at the end of the floor, the rightmost node, you'll add it to the result array. And now you can simply return your result. Let's run the code. And that gives you the correct solution. And once again, to go over the complexity, it is O of n time, where n is the number of nodes, and space complexity will also be O of n in the worst case scenario where you only have 1, 3, and 4, for example, where you only have nodes on the rightmost side. And then in that case, every single node, which is n, will be in your output array in memory. Thank you guys, and be sure to like, comment, and subscribe.